YouTube. Today we have a very interesting video and I think you will like it a lot because it is a new device that has to do with universal charging of electric vehicles from renewable energy sources, for example from solar panels. And when I say universal, I mean that the voltage output is adjustable so that we can choose the voltage according to the voltage of our vehicle. Today we will do several tests like connecting solar panels, power supply and batteries to the input of this device to see if we can use it in an emergency situation when a vehicle goes down from flat battery, so that we can charge it from other vehicle to continue his trip. Something like SOS Charger, for example. As you can see, this charger is MPPT, maximum power point tracking. It can deliver 300 watts to our vehicle. The input of this charger is from 13 volts to 45 volts and the output can adjust from 29 to 85 volts. That means I can charge 24 volt system of electric vehicle, 36 volt system, 48 volt system, 60 volt system and 72 volt system. This is pretty nice because I can charge many type of electric vehicles, from scooters, electric bikes, electric cars, electric motorcycles, everything. If you see here, starting voltage of input is from 13 volts and output from 29. That means this device is only step up. So if we need to charge 48 volts flat battery on this device, as we know 48 volts battery, the lowest value it will be about 38 to 40 volts. So to charge with this device we must put lower voltage. If we put higher voltage from the battery, for example 45 volts input and the output which is on the battery is about 40 volts, we will pass straight all the power from input to output and we will burn our fuse. Today's experiment, it will have these two power meters, battery coulomb meters. One it will be connected to the input and the other one it will be connected to the output. Like that we can see the input and the output amperage to see how efficient is this device and how many power it delivers from the device to the battery or from the solar to the device. Tomorrow we will test it with this solar panel, which is only for test. It's not big panel. Tokyo solar panels at 40 watts, 18 volts, at 2.22 amps output, maximum power current. Very nice panels. So let's start and make some XT60 connectors on the device and connect it to power meters. now. So this side is output and this side is input. Before to make the experiment, I want to open the device and to see the electronic circuit and the components on the board before do any test on this device. So let's open it. Okay, so this board is much more smaller than I thought. So what we have here, two big capacitors, one inductive coil, two MOSFETs, nothing else. And the second board, which is for the LED screen indicator. I'm not sure that this thing can handle 300 watts. So there is one way to see that. Let's do the experiment. Manual. As you can see here, the solar panel which we can connect on this device is from 12 volt to 50 volts, 18 volts maximum 200 watts or 36 volt maximum 400 watts panel. MPPT voltage range from 13 to 50 volts, maximum charging voltage of the battery pack 48 volt system, 60 volt system and 72 volt system, and efficiency more than 19%. Yeah, we will check that. Here you can see wiring diagram, how to connect the panels. We can connect them in parallel, connection in series. Experiment, we will use a big battery at 60 volt system. We will connect it to the output of the device. So here is our output from the device and it will go to the battery. So here small spark and the power meter is activated now and show us 63.3 volts. Now to the input, we will start with the 36 volt charger and see if lower voltage charger can charge this big battery through this MPPT device. And most important, how efficient this device delivers the smaller voltage power to high voltage battery. Here is my 36 volt charger, 36 volts DC, 2 amps. Let's connect the charger. It's on. For start, I will disconnect the battery. Okay. Now we have voltage. On screen I have 42 volts. On the charger I have 75 volts. This voltage must be the output of the module. Yeah, we have voltage here. On the second screen it is about 75 volts. So this indication is accurate, 75 volts. Okay, so if I keep the button of the, so here we have DYE. Now I can adjust my voltage. For this battery we will need 67.2 volts. We must reduce the voltage, but I will increase the voltage to see the maximum voltage output from this device. The maximum voltage output is 85 volts. So let's decrease the voltage to our battery, which is 67.2 volts. This is a little bit annoying. The buttons is too small. 67.2 volts. Now it is ready. Our screen says 67.2 volts. Pretty accurate. I like it. The screen, the voltmeter here is too accurate. So now let's connect our battery. Nice. We see amperage from the output. We see that the battery is charging now. So now we have input of 42 volts. We can see here the screen of the charger. This is output, 63 volts and 1 amp charging. We have output of 72 watts, 75 watts, 76, somewhere there, and the input is also about 74-75 watts. So guys, this thing is too efficient. The device is cold, it's not warm at all. The fan is not running now because it's cold. So we can charge also with the charger. Now let's see how it will be respond to charge battery to battery. Now we have battery at 36 volts. Now we have 37.5 volts on input, and now let's connect the output. From the output I have 5 amps. Nice, it is about 300 watts. Let's see on the screen. Yeah, we have 300 watts here, 310 watts. And on the input I have about 10 amps, 320 watts. Output 306 watts. So let's see how efficient is that. So this is about 95.6% of efficiency. This is much more better from that the factory says. Other thing just I found now is that if I push the minus button and keep it like that for some seconds, it will show the input. I will see the output, which is 64 volts and 5 amps. Now I can see the input, 33 volts. Very nice thing. Just now the fan was activated and closed again because it's not warm at all. I will search other devices of this kind of MPPT controllers, which is designed for EV vehicles, and we will find the best one. This is the most cheapest and smallest one. It's working fine, and most important is that this thing is too efficient, at 95% of efficiency. Now let's try different battery with lower voltage. I will put drill battery from Parkside company, which is at 20 volts, 4 amps of capacity, and see how this MPPT charger working at lower voltages. Okay, now we are connected. Output voltage is at 67 volts again. This thing remember the output, so we do not adjust the voltage every time when connect the power on this device. This is very important thing. Now let's connect big battery. Okay. Oh. We have 10 amp input here. Yeah, this thing limiting the input power at the 10 amps. We have 9.6 amps input. Now let's see the output of the device. The output is at 64 volts and 2.2 amps of charging. So let's see the efficiency at these voltages. Let's see them together. As you can see, the efficiency gain is pretty good. 160, 150. So let's check the efficiency. So at 20 volts we have 93.7% of efficiency. Again, is very good. I hope there are existing same type of these devices that can make step down and step up conversion. So the last test will be with a solar panel. So let's again adjust the voltage at 60 volt system. Now we have power from the solar only. Yeah, this button needs too much patience. So here is our input at 21 volts, very nice. And here we have the output at 67 volts. So let's connect the battery to see the charging process. Thirty-seven watts, 38 watts, and in the output we have 35 watts. I am moving the panel now. So the pluses of this device: first one, nice and small device. Second plus is that this device has a LED screen in which I can see the amperage and voltage from input and output. Very good plus for this device. The third plus and most important plus is that this thing is too efficient and can reach at 95% of efficiency. This is very good thing. The minuses is that the buttons here, they are too small, and for adjustment you will need some time. And the second minus is that, as I said before, this device can make only step up conversion, not step down. So this is a big disadvantage for this device.